Today we're going to do our second lecture on electricity. We're going to focus on the uses and various forms of uses of electricity and how we will encounter these uses in practical situations. First of all, as everyone probably well knows, we use electricity to light our homes, and we use something in the past that was called an incandescent light bulb. This shows the typical incandescent light bulb with a filament which can be made of various materials based on their ability to conduct electricity and also to last. The inside of this globe is evacuated from air and then filled with an inert gas that doesn't burn, and then you have conducting wires which are made of iron or lead. So an incandescent lamp is a device that uses electricity, and this electricity heats a filament, and when the filament is heated up, it glows and produces light. This is a rather inefficient way in which to produce light. The filament is the thin piece of wire in the lamp that produces the light when heated by the electricity. Silica you'll notice that many light bulbs have a sort of white frosting looking appearance, and silica is used in order to produce that frosting. This is to reduce the glare from the light. Halogens such as bromide and iodine can be used to help preserve the filament. When a light bulb burns out, essentially what happens is the filament breaks because it wears out as it goes along. You'll also notice in an incandescent bulb that over time there's a sort of a black or a dark staining that occurs on the inside. This is the filament breaking down and dropping onto the globe. Now, as time has passed, new types of light bulbs have been developed, and this is called a fluorescent or a fluorescent tube light bulb. And the way a fluorescent tube light bulb works is you have the electrical material or electrons will pass through a gas, and this gas is then excited by the energy of these electrons, and that causes them to glow. Now, if a gas is mercury, it's called a mercury vapor light, and it glows a sort of purplish color. It can also be used, sodium can also be used in this situation, in which case it generally glows a more reddish or yellowish hue. Now on the right here is a typical CFL light, which is the kind of lights that are now used in homes, and these have replaced incandescent bulbs because of efficiency and efficient use of electricity. So a fluorescent light is also called an electric discharge lamp, which produces light because you pass electrical charge through a confined gas, and the gas glows when this electrical charge is sent through it. And the reason it glows is the electrons in the actual gas molecules, because of the increased energy, move up in their orbit, and then when they drop down into their normal orbit after the electron passes by, energy is released, and that energy is in the form of light. This is much more efficient than the incandescent bulb. And various gases are used. The most common are mercury and sodium. Also, mixtures of mercury and argon or mercury and sodium can be used. As I said, the CFL bulb, which just stands for compact fluorescent lamp, is essentially the same kind of bulb, except you've miniaturized the glowing part so that it can be about the same size as an incandescent bulb that's used in the house. Another type of light bulb, two other types of lights are shown here. On the left is a neon light, and on the right is what's known as an LED, light emitting diode. On the left here, the neon bulb works in a similar fashion, to the incandescent bulbs. The neon lamps are another electric discharge lamp in which neon is used as the gas instead of mercury, and generally this will glow in red. You see these open signs and closed signs. Various types of signs are used with this mercury, with the neon. On the right here is a light emitting diode, or LED. An LED is a semiconductor. Semiconductors are materials that neither conduct or fail to conduct. They're sort of in between in terms of their ability to conduct electrons. And they emit light when a direct current is passed through them. These are used in things like calculators. They're also on your phones, things of this nature. They're small. The reason they're not more commonly, they're very efficient. The reason they're not more commonly used is because they require complex wiring. And it says LED lamps here are extremely efficient. It's very uncommon for the lights in a calculator or in a phone to actually burn out, if you will. But because the wiring is complex, they don't use them routinely in homes and things of this nature. Now, there's also, we had talked about this before, about ways in which magnetism and electricity are produced. And as it turns out, electromagnetic force, which is these purple lines that are shown in this diagram on the left, it's one of the four fundamental forces in nature. And electromagnetic force requires both magnetism and electricity. What the attempts to show is the current, which is the I on the diagram on the left, is entering on the right side of this diagram and exiting on the left side, and then the process is moving through this coil, and it generates the magnetic field shown as these purple lines of force. And you can see that basically by convention, the north is on the right, the south is on the left. Now, on the one of the fundamental things to remember is that electricity can be used to produce magnetism, and this is an important and, magnetism can be used to produce electricity. Most generators that generate electricity use magnetic fields to do that production. And a solenoid is a device that converts electricity from back and forth motion. And this is shown on the right here. What you do is you take a coil, and you move a plunger in and out of this coil, which would be up and down on the diagram as you see it here. As that magnetic plunger moves up and down through this coil, it will generate electricity and allow that to be used. You may have seen this. There are actually flashlights where you can shake the flashlight, and in the process of shaking the flashlight, a magnet moves through a solenoid back and forth, and in that process, then it generates electricity and lights, which is used to light the flashlight. And then conversely, you can pass electrical current through the coil on this device on the right, and it will cause the plunger to move up and down, which is actually what this device really is. Both, in either case, depending on whether you supply the mechanical energy in the form of motion or you supply the electrical energy, you get the other out of it. So a telegraph is a device consisting of a key or a switch and an electromagnet that's used to communicate over large distances. So when you close the circuit, the electromagnet then causes the other end to click so that you can hear it. So here's the an example of a telegraph, and you have the electrical power here, and you have a electromagnet here, and this can be a very long line. It can be miles long, okay, and a person is sitting on this side, and they push this down and complete the circuit. When they complete the circuit, the electricity runs through this. When the electricity runs through this coil, it magnetizes this bar and pulls this down. And when it pulls this down, then the buzzer buzzes or the light bulb comes on. And so when this person wants to communicate, and again, this line between them can be miles long, he will tap out Morse code here. That's why it's called Morse key. Morse code here. And every time he taps, short or long, this light lights up short or long, and that's the way a telegraph works. Now, a relay is just a device that uses an electromagnetic switch in order to open and close a circuit. So this is actually a relay on the right here. And what we have here is, here's the electromagnet here, and you have the circuit here, and then you have a high current circuit here, which is open. So this is a relay that's not that's at rest, or is not allowing electricity to go through. And then if a person turns something on or pushes a button or whatever, this electricity goes through this coil, magnetizing this and pulling this shut, and then this relay pulls this and closes the circuit here and allows electricity to pass through. So in this way, a person here can push a button or flip a switch or whatever you want to say. When they do that, electricity goes through this, causes this magnet to magnetize, which pulls this shut, and then allows this at a distance to close and then operate the electricity. Now here we have two sound devices. On the left we have a loudspeaker. On the right we have a telephone, or the way a telephone works. So a loudspeaker is a device that converts pulses of electricity into sound. And what you can see is the electricity comes in here and goes through a coil and then exits here. So that's the circuit, okay? And when it goes through, there's a magnet around where the coil is. And when the coil is the electricity flows through the coil, it makes the magnet vibrate back and forth like that. And when it does that, it causes this cone to vibrate. And when the cone vibrates, it produces a sound. And so, when you have a big cone like this, you can take a small sound and make it bigger such that you can hear it. This shows the same thing. You start out with a current going through a coil with a magnet around it. The magnet begins to vibrate, and when the magnet vibrates, it produces these sound waves that come out from right to left here. Now, on the right here are the parts of a telephone and a microphone. This is a microphone here, which every telephone has a microphone in it, and here's the ear part of the telephone. And again, you have the two things just working, and one works opposite the other. That is, this is set up to convert the sound waves by vibration into electrical signals, which go through a phone line. And then on this end, the electrical signals are then converted into vibrations, which turn into sound waves. And so what you have here is just going one direction this way and the other direction that way, going from sound to electrical signal on this side, going from electrical signal on this side to sound over here. So you speak here and listen on this side.